Hey guys, welcome to CPG's Ask an Expert. I'm Kirsten Stone. We're going to be working here with Billy Godbold to pick his brain. He is the official CompCam's brain trust, so he's got all kinds of information in there that we want to pick out. I am going to go ahead and share this video to my own personal feed. I'm asking Billy to do the same. If you're on the feed now, go ahead and share that for us. We'd really appreciate it. And we'll be back with you in just a second. Hope everybody's enjoying their Friday afternoon. We're just about to the weekend. That means it's almost time to go racing, you guys. And speaking of racing, Mr. Billy Godbold has a Frankenstein creature of his own. You want to tell us a little bit about that BMW?
Well, you know, I read the rules just like any good racer. You know, a good racer tries to read the rules 3 times. The first time you read it for what it does say.
Sure.
The second time you read it for what it doesn't say. And the third time you read it to figure out how they check it and how much spacing there is between where it does and where it doesn't say. So I was looking through chump car rules. I love road racing. I think it's fun. I love endurance racing because it tests the components for such a long time compared to drag racing. You know,
right.
Talking
it's
about
testing.
12 hours, not 6 minutes or 6 seconds. So I was reading through the rules, and they had this deal in chump cars, like the value of the engine transmission in versus the value of the engine transmission out. And I'm looking through different cars that you could choose. There's like a BMW there, and I'm like, well, hold on, that engine transmission has to cost a lot.
Yeah.
So I looked at the engine transmission for a Suburban or, you know, Silverado.
Right.
Like versus the BMW. I'm like, okay, I'm going to do this.
LS truck motors.
LS truck motor in a BMW. Well, somebody else beat me to it, put a small block Chevy and Miata, but I'd already built my car basically. So now instead of being the regular class, I'm in the experimental class. And so we have like we might have 150 more horsepower than anybody else out there. And it's an absolute blast to take the car out to the track.
I haven't broken any rules yet.
Now, I haven't broken any rules. I've broken everything else you could possibly break in the engine, transmission, and everything else, but I have not broken a rule so far.
Yeah. And how much power does that thing make? Because I know we've had it on the dyno here.
580-ish.
That's pretty good in a little bitty BMW.
Yeah, in a 2,800-pound car.
Yeah.
It's exciting.
That's awesome.
Yeah.
So, Billy Godbold, for those of you who may not be totally familiar with him yet, I'm glad you get the opportunity today. He is a nuclear physicist.
Yeah. How do they put the bubbles in the soda pop?
Yeah.
Actually, one of the NASCAR guys asked me that. They're like, oh, he's a nuclear physicist. And, like a guy named Mike Egge, who was head of Penske on Penske's Cup program at the time, Engine Pro. He goes, so how do they put the bubbles in soda pop? And I'm like, that's not the type of physicist that I am. No, but my background is from Florida State University. I had a PhD fellowship in nuclear physics. With physics, you got to choose which.
Right.
Where nuclear guys, our things go faster.
Yeah.
So you know, we thought that my experiment was like 0.98 the speed of light, so it's kind of fast. So it was a hot ride, you know.
Do it.
Yeah.
So how does that lead you to CompCamps? Because that's a.
Well, I'm actually from this area, and my first wife, our kids, she wanted to be back toward here, and we wanted to move back here. I was going to go into medicine or something like that.
Yeah.
I went to work here on a job post because I used to I used to drag race or do mud drags in a Jeep.
Yeah.
So, you know, I was kind of a little bit goofy. So I came here, I was going to work here between semesters, and that was 23 years ago. And still haven't changed jobs yet. It's fun. I go home and like everybody knows I was a physicist. And they look at me like, where are you going to grow up and get a real job? Like, I get to play with some of the coolest stuff in the world. I have great relationships. I love what I do.
And so you are the engineering manager for all of the Comp Performance Group.
All the valvetrain side.
Okay. So how many guys are working underneath you at this point?
Well, you know, we have a team of guys. I'd say through the whole deal, we're about 25 to 30 different guys between those that are working in testing, electronics, mechanics.
All right, we're live again.
Hey guys, welcome back.
Hey.
I'm going to go ahead and reshare this version. Apparently we had a little bit of an issue, so we want to make sure nobody's missing out on the opportunity here. We will jump right back into it in just a half a second. I'm sorry again, you guys. But tell us, while you're hanging out there, where you guys are watching from in the country so we know who to report you guys to for not working on a Friday afternoon.
My boss knows I'm here.
So we were talking to Billy a little bit just before we cut out about how he went from studying nuclear physics to working at Camps, he was talking a little about, I guess, dirt drags and. Or
Oh
mud
yeah,
drags.
doing mud drags and a Jeep. But no, it's great to work here. You know, that's kind of what started my whole deal. From the time I grew up, I'm a farm boy from Mississippi.
Okay.
We hot rodded everything.
Right.
Boats, tractors, lawnmowers, chainsaws, anything. And so I did that all through school. And it's kind of cool because my passion was always racing and my career was physics.
Right.
And then I came to work here and like everything got flopped over.
Yeah.
Now instead of, you know, like I keep up, like I can tell you the path of the solar eclipse coming up.
Right.
But that's what I play with. What I do
Right.
for a living now is actually trying to make cars go faster.
Right, and you definitely have the background to do that in ways that nobody else can.
Well, it's just fun. We've gotten to work with all the best race teams. I mean, when I was 24 years old, the first guys I worked with were guys like Grumpy, Steve Schmidt,
Right.
you know, Doug Yates when he was just a kid. You know,
Right.
we were playing with everybody that you could imagine. Bob, you know, Bill Elliott, Bob Glidden. just-
Right, and it hasn't been that long since Memphis or this area was just an absolute.
Oh yeah, I
boom
mean,
town
if
for
you
it.
go back, I mean, even the cult following, two-lane blacktop.
Right.
Filmed at Lakeland Dragway. My
Right.
first house in Memphis wasn't 100 yards from the starting line.
That's awesome.
Yeah.
And Lakeland Dragway,
Yeah.
may it rest in peace.
Oh yeah.
So we're going to get into, we grabbed a couple of questions off of the last feed, and we're going to go ahead and jump into one of the first ones. Someone asked, when is a good time to choose bushing or needle lifters on a solid roller cam?
Well, that's actually an excellent question. If you think about it, you'll have guys out there going, needles, needles, needles. They're always right.
Right.
Then you have guys going, oh no, bushing, 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 and that's always right. And the truth is, there's a little bit more going on there. They both have their advantages. They both have their disadvantages.
Right.
The bushing guys won't tell you that, hey, a needle bearing takes less oil to feed to let it go.
Right.
So the less oil that goes in your crank, less windage. A needle bearing is lower friction. So it actually doesn't wear out the camshaft as quickly.
Okay.
The thing that a needle bearing doesn't do well is if your valvetrain's out of control, a needle bearing
Yeah.
can't handle that loft, that separation, that impact. So you're bam, 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 and you do that. And the needle bearings, they have to focus all of that load on such a small little area of the needle. Eventually it'll
And
spall and
that's
fail.
what I was going to say. That's where you see them scattered through a motor.
Right, you see the needle all scattered through the motor, and people go, oh, it's the needle's fault, it's the needle's fault. No, it just was asked to do something there's no way it could possibly do.
Right.
But if you look like NASCAR requires, because they're worried about loft, they require needle bearings.
Right.
So if you look at all the NASCAR setups, they're all needle bearings. You go look at the guys who run like the 24-hour Le Mans, all of those will be needle bearing bushings. You look at the guys who run down Australian Supercar, those motors have to go about equivalent to 48 hours.
Right.
All needle bearing. If your valvetrain's under great control and you're not hitting a rev limiter, you don't have a turbo that's on a boost controller,
Right.
you're not going out of control, a needle bearing's a great way to go. But if you've got something like
You're slapping
maybe
it
a
together in the garage.
yeah, well, no, or like take guys that are running World of Outlaws, where they
Right.
might be up on the rev limiter a whole lot. If those guys, they almost all of them probably run a bushing because the bushing has some more robustness. And if you're running a turbo car with that wastegate, that boost controller,
Right,
If you ever
where
gone
you're
to
on and off
watch,
it.
yeah, if you go through the staging lanes when some guy's trying to leave that,
Yeah.
it sounds like just torture what they're doing to
Yeah.
the poor valves. So on those guys, I've seen guys try to run needle bearings in those and break four lifters all on the exhaust side in the first pass.
Just because it's such an erratic motion.
Right, it's such, right, combustion on that side of the valve
Yeah.
tends to lift it and you get separation. You get
Yeah.
separation, stuff tends to come back together. It's bad, it's ugly.
There was a follow-up question on that one,
Sure.
asking, are bushings really not good for the street?
You know, I don't know if you could say that. I wouldn't run them myself in a street application.
Mhm.
But say if you had a street application that wasn't a lot of use, but it had a turbo and you had a boost controller.
It's
I
your
think
Friday car.
right, I would might, that, it'd be a really good.
Yeah.
So how about maybe?
Okay, I'll take it. So it's highly dependent. Don't forget to call our tech line if you have any questions on that, you guys. When it comes to, let's see, polishing a cam, you've told me before it's not all it's cracked up to be. Do you want to elaborate on that?
Well, we've done a whole lot on topography. You know, it's important for us to try to understand what the surface of the cam looks like.
Right.
You know, we have the AGCOs can measure around, but we've just invested in a Zeiss skidless profilometer so we can really look at the whole roughness, the contour. No camshaft actually fails globally. The whole thing just doesn't blow up.
Right, there's a load.
It always fails at a microscopic spot.
Right.
It fails at that one spot because the load at that spot exceeded the strength of the material.
Right.
So a lot of people think, okay, I'm going to polish it, and that's going to make the load not very good. You know, the analogy we have is, say somebody told you, oh, I want to build a major league ballpark.
Right.
Okay, what tool do you have? I have the best finishing mower in the world. It's the same one they use at Fenway Park.
Right.
I'm going to go out there and take that hill over there. We'll go with the finishing mower, and it's going to look just like Fenway.
Not so much.
No, you've got to have a bulldozer first. Then you need a grader.
Right.
Then somebody's going to come. There's a lot of prep work. And that's why some people talk about polishing being like mowing the grass. If you have a beautiful lawn and it's just a little bit erratic, you can polish it
Right.
and you can make it better. But if you don't have a good system to start with,
Right.
you go in there and polish it, you just make it worse.
You said earlier, if you don't bush hog it first, the finishing
Right.
mower is not going to do the
Right, the
trick.
fishing mower's just going to hit some truck dirt and rip it all up and make everything worse than it was to begin with.
Yeah, so that's an interesting point. I know that polishing a cam is something we're hearing about a lot, especially in the media these days, so definitely bear that in mind. Hey, you guys, do we have viewers here? It seems like maybe we may be having a transmission issue again. Just wanted to check in with everybody. Give us a love reaction if you're out there and you can hear my voice, because I'm seeing that we've got 10 of you there. And if Cindy over in the Comp HQ is tuned in, I'm thinking maybe we got to share it again to some other pages. So, sorry guys for the interruption. We'll get right back into it. And actually, we've just had a special guest enter the room, you guys. Mr. Scooter, would you like to join us?
Uh-oh.
I know, we're all in trouble now. Boss man has entered the room.
Yeah, this is never good.
It's probably not good at all, because I heard you talk about lofting and tearing up parts, and
I never do that.
I mean,
I
you're the
lied.
worst I've ever seen at tearing up parts. 'Cause
Yeah,
whatever parts there are, you can figure out how to break them. But, you know, you were talking about in control.
You're right.
How does a normal guy know if his valve train's in control?
Well, I mean, that's a really good question. One of the things, Canary and the Cape.
They don't have
Right.
Spintrons.
You know, the easy way to do it, like if you're me, you go up to you and you say, hey, Scooter, I need $1 million for a Spintron cell. I need $100,000 for this laser. I need $20,000 for this
And what do I
proximity.
say?
You take a lot of no's before you say yes, but generally I got all that stuff. But, you know, if you're just the normal guy out on the street, one of the things that you can do is take apart your valve train periodically. Take apart, look at your locks and retainers. One Canary in the cave mine, Yeah, no, coal mine, there we go. Yeah, the Canary coal mine will be looking at that lock. If that lock is polished on the outside or that retainer is polished on the inside, something that was supposed to be together was apart. Looking at, you know, a lot of people have log spring loads. I think you taught me all this, by the way. You know, go in there and, you know, check the head-on spring checkers aren't great for accuracy, but they're pretty good for precision. Meaning you can check, and you pull down, it says it's 200 pounds on the seat. That may not be 200 pounds. But if you pull it down 10 times, it's always 200. It's a good number. And then if you see it drop down to 190, watch that, 180, watch that. But if it ever, you know, it should drop a little bit, plateau. If it drops again, it doesn't
Well,
matter. If it just keeps going down, you've probably got some bad valve train.
One of the things I was kind of getting at is there's a lot of people out there driving cars that are high performance,
Mhm.
they're having fun,
Yeah.
that are never going to have their valve covers off. They're never going to know. They don't have a Spintron. They don't have any of that stuff.
Well, then you're.
But
then-
what they do have
Yeah.
is an opportunity to talk to somebody that does have it.
Right.
And that's one of the things that I wanted. I mean, I know you and I battle all the time about your toys,
Yeah.
and
Daily.
yeah, but I'm kind of proud that we've been able to put these toys together that help the products. You know, that people can dial up 100 places and buy a good cam.
Right.
And it doesn't matter if we're talking about valve motion, or it doesn't matter if we're talking about surface finish or polishing or whatever. You can call anybody and they're gonna tell you it's the best cam.
Mhm.
But one of the things I'm most proud of is what we've put together before we ever have the idea to make a cam.
Right.
You know, we don't know if we're gonna make a cam for a Chrysler or a weed whacker,
Right.
but
And we've done
everything-
ships and weed whackers.
We've done all that, but the fundamentals are the same.
Mhm.
And my suggestion to those who view this is make sure that whatever cam you buy, and, you know, I want it to be ours, but I want to make sure that whatever you buy, that it's backed up by some of the things that we're talking about here today. Because all these things happen way before the cam ever gets designed or ground or put in the engine or has a chance to fail. So, you know, it's easy to buy a cam and pull it out of the box. And the only thing that you have at that point, the only thing you have to check surface finish is your eyes.
Right. Right.
And that's
No
okay.
profilometer, no.
That's okay. That is one way.
Yeah.
But you got to make sure that whoever put the cam in the box on the front, who ground the cam, who designed the cam, who tested the cam, that they had all the knowledge, all the equipment, all the background, everything that it takes to make sure what came out of that box is going to do the job. And it's a hell of a lot more than the way it looks, the way it feels, the way the ad you read, or there's so much that goes into the making a cam that's not in the cam. You know, it's the things beforehand. And anybody with a credit card can go buy a Spintron, they can buy a AdCol, they can buy a CNC grinder, they can buy all that stuff.
It's a good credit card.
A pretty good credit card. But that's not important. I mean, it is important, but it's one piece of the puzzle. It's all the other stuff that it takes to make sure what you tell that polisher to do, what you tell the grinder to do, what you tell it to do is correct. And that's what I'm proud that we put together with your team.
Yeah, what I was going to say is that the thing I see in our industry, especially on the street side, that kind of breaks my heart, is a guy will go out there and buy what he thinks is the best rocker arm. And he'll go out and buy the best cylinder head, and he'll buy the best valve, he'll buy the best, whatever it is, this lifter, this Pushrod, this valve spring that, hey, my buddy Phil runs this spring, and this guy over here runs this rocker arm.
They're all great parts.
And they're all great parts. You know, at least 90% of them are.
Good
Yeah,
parts.
maybe they
Ours
have
are
a
great,
couple of
theirs are good.
Right, they'll have a couple of things, but they'll take and put this together, and they'll put together something that's the, 3 hot trick of the weeks off the internet. They'll do a couple of things that, I'm on the internet saying that, that's wrong. They'll throw this thing together, and they're expensive parts. Most of them are very good parts, but they'll have a great parts, but not a great package. And one of the things that I try to convince people to do is to call into our tech line, work with somebody that you trust, establish a relationship. We'll help you with parts, even if one of the best parts for your application isn't ours.
We do it all the time.
Right. If somebody has a valve you should run, we started playing with LSs, right when the LS first came out. And we thought all LSs were the same. And it didn't take very long to figure out that an LS1 acts different from an LS2 with the tie valve, acts different from a L92 with the big heavy valve, acts
Those were
different.
expensive lessons we
Yeah,
found out.
right.
And I'm glad we found them out before
Right.
the customers had to
And
find
that's the
out.
nice thing. When you have dynos, I guess we have 2 Spintron rooms, we probably have 5 Spintrons now. When you have all the testing, we have 5 guys working in engineering who do nothing but testing now. When you have that
Wish
type
you
of
hadn't told
resources,
me that.
I'm sorry. When you have that type of resources, you can go in and actually test these packages and help put people not into the trick of the week camshaft, but into a package that's going to perform the way they want to.
I remember, excuse me, but
Sorry.
I remember one very prominent motorcycle drag race team
Oofa,
that we work with.
yeah.
And, we only work with one, so it's not a big deal, but they came to us and your guys picked them up like 16 miles an hour and didn't change the cam.
Nope.
And that just proves that
We changed the cams later.
later, sure.
Yeah,
But in first crack,
no.
didn't change the cams. And I remember arguing with the people and they said, that's not gonna matter, it's not gonna make any difference. And I remember hearing you say, you gotta trust me. And sometimes that's hard to do, but it is more than a cam. It's more than is it shiny when it comes out of the box? It's more than,
It's a package, it's an engineered system. The valvetrain, more than any other components in the engine, if you don't treat valvetrain like a system, you're gonna get in huge trouble.
and you can't look at it.
Chris is gonna kill us.
I know, that's all right.
I'm just consider it.
She can't say anything.
I'm sorry.
What's she gonna do?
For anybody out there, Scooter and I
That was a really
argue
good
like this
threat
all
if
the
I've ever
time.
seen one, you
Yeah,
guys.
every day.
I just want to say thank you to Lee Harrison, who's been a loyal customer. Says we've got the best customer service he's ever seen. We
Wow.
really appreciate that.
We
Wow.
got him
And,
fooled, haven't we?
I'd say so.
Oh, the push rod?
And then we've had, there's a question about properly measuring push rods. Before we jump into that, we keep dropping the word Spintron into conversation like everybody knows what it is. And I'm going to make the big assumption that most of the audience probably doesn't. So I want between the two of you to describe what the Spintron is, how it works, and then the question was actually, what's the highest RPM we've hit on the Spintron?
Okay, I'll go last first, 17,500.
There you
Now
go.
go back to let's go, first last now. Scooter, and I like to brag him on this. This is when I was riding, I don't know if I had training wheels off or not. These guys were crazy enough, they took a 2-barrel 350 Chevy through one transmission, ran it to another transmission, back to another Chevy, that they had gone in and taken the pistons out but put bob weights in it, and ran the camshaft through the other dummy crank, and ran all the valve train. Now this thing, you put it in the wrong gear, there are still push rods in low Earth orbit. NORAD was calling them up going, what was that just came out
I
of?
mean, we had no idea what we were doing,
So,
but we weren't smart enough to know we shouldn't be doing it, and we just went in there and tried it, and
Just push it.
yeah, I mean, we didn't have anything to measure it with other than our ears, which is a really good tool, and our eyes, which will fool you most of the time, and a strobe light.
Yeah.
And then
and parts stuck in the wall.
my
That's
dad,
a
when I
solid
was a
indicator.
little bitty guy working on cars, I asked my dad how to find a short in the wiring harness. And he said, well, you take out the fuse and you put a bolt in there and you watch for smoke. And you'll find it.
Right.
And that works with Spintron, spin fixtures, valve, whatever. And a Spintron is a fancy name for what we early called a spin fixture, which is just a dummy engine where you operate the valve train by some other power source. Then we used a 350 Chevy. Now we use a 100 horse or 75 horse electric motor and do it. But we were having to plow new ground back in those days, and we didn't know what. It's even worse because the chassis for that thing originally was a 68 Chevelle.
Oh my goodness.
We just got a 68
Engine on both
Chevelle
sides.
and whacked the thing in half and put the other transmission up to it, and away we went. So,
But yes, to answer what he said, he's exactly right. A Spintron is just a spin fixture. We've had 20 generations of them. The current generation is a piece made for trend. It's a 75 horse AC drive. We can put in any RPM signal we want. Now, most people use the trend system just like it is. And they run up there, it runs up and down. We do something more than that. We have National Instruments work with us on a data acquisition system.
Right.
So we can bring in at least 8 channels, 1 degree plus accuracy at 20,000 RPM.
and all that just means money.
We get
I mean,
we have spent a lot of money making our Spintron cost more than everybody else's.
There's a lot of Spintrons
Yeah.
out there.
Yeah.
A lot of people use them. But the only thing we use from Spintron is actually the piece that spins our fixture. Everything else we made.
It's Comcam's Frankenstein.
We
Yeah.
designed all that stuff, and I'll go back there sometimes and there'll be 8 or 10 laptops hooked to this thing, and 8 or 10 people looking over the laptops doing this while it's running at 10,000 RPM, and it's crazy. However, they'll have, a thing called a strain gauge, which is just a way you measure what's going on inside a part like a valve spring. And they'll have wires running out of this thing, and they'll have strain gauges on the valve and the push rod and the load cell under the spring and all kinds of crazy things. But that's where you look for what's really going on, and you don't look for the results of what went on.
Right.
That's what I'm talking about, the background. You gotta know what it's doing, what little things you can change.
Before it goes.
If you want to see him get really crazy, we take all those wires out of the Spintron cell and go run half those parts over into a dyno cell. And you got a motor going 10,000 RPM, you got wires running in the oil pan in there and going, what do you have wired up? Don't worry, it won't
We
stay
just
there
want
long.
to see what happens.
Right, yeah.
There's a whole lot of this stuff I'm way better off not knowing.
Oh,
That's okay.
and just so you know, even though there's no fuel going into a Spintron engine, you actually can create a pretty good fire in one.
I know.
Because if you get it hot enough, the
Discovery.
I
oil.
saw them come out and say, "Don't worry, the fire's out." I thought, well, that's really good news.
But titanium will try to weld the titanium, so if you have like a Hemi head and the valves start welding to each other while the oil is starting to evaporate
Means
because
we've
it's so
gone a
hot.
step too far.
Yeah, it'll actually create a nice little fireball.
It's an interesting
Yeah.
time.
So you mentioned about like having 8 channels of data acquisition on that.
Yeah.
What kinds of things do we measure? What are we looking at?
Well, we can put strain gauges, like you said, strain gauges are basically just a resistor.
Right.
You put it on there, and if something changes shape, it changes the resistance.
Right.
You know, common things to strain gauge are like push rods. So you can measure, like, put a strain gauge on both sides. As it bends, one will get longer, one will get shorter, and you can tell how much load's on it. You can actually look at different ones and see how much it's bending, not only just how much compressing.
Tell them, just as a matter of
Yeah.
record of measure,
Yeah.
a top fuel push rod.
Oh, yeah.
We put a strain gauge on there and took a little bit of data before it broke. But I don't remember how much.
It was-
a NASCAR engine was like 21,000 pounds of pressure on the push
Yeah,
rod.
we don't really know because usually, as long as everything's in control, a NASCAR deal runs about 6 to 8. A pro stock can be like 8 to 12,000. Pounds. 12,000 pounds. And think about, this is you're talking about, 3,200-pound car,
You put 4 of them on top
Right.
of something that's as little as your pen.
right, pro
You
stock,
stacked
you're
up
talking
here and
about
you're telling it not to bend.
2,500-pound car, you've got 4 cars worth of load momentarily on each push rod as it opens the valve. But as soon as we whacked the throttle, the guy had, it's Clay Milk, and
Right.
he had Clay's a good buddy of ours. Thank goodness he just won. That was awesome. He had a thing on jack stand, switched over fuel, gave it one whack of the throttle. Before it even really got loaded, it was past 15,000 pounds going up. And then the problem is the mags fried
Right.
our whole data acquisition system. And I mean, when I say the mags fried our data acquisition
Oh,
system,
yeah.
That
I
was
mean,
not
literally, that's not figuratively fried, that's like the inductance of everything just
Yeah.
smoked.
I've seen that on electronics.
Yeah,
Right, quite
it didn't
before.
like it.
It's
Yeah,
a mess. So since we're on push
I'm sorry,
rods-
rabbit. Yeah.
No, you're fine. One of the questions that came up was about properly measuring push rods using the comp tool. Do you use the final measurement on the tool, or do you have to add a couple mil for the lifters?
One of the things that you want to do on that is just come up with a consistent way to do it.
Okay.
Push rods, there's the end-to-end length like you measure with the real long calipers versus the gauge length. And there are people who are like religious fundamentalists on which one's the right number. Is it the gauge length or is it the other? What you find out is as long as you measure it the same way every time,
Right.
you're going to be great. The problem is when you start thinking about the effective length versus the gauge length.
Right. Or
I
if,
don't-
you're only measuring push rods once a year on the higher end, let's say for the average streetcar guy. So
Normally
you don't know
10,000
what you did a year ago.
Unless you're trying to run a solid roller, like we have a new XDA push rod, which is that 3-piece push rod.
Yeah.
The only time where 1 or 2,000 starts to matter is when you're trying to set lash with it. Then all of a sudden you're out there with a block and doing figure eights,
Right.
trying to lap down the lash.
There's not many people that have any idea what you're talking about.
They're cool though.
But when, I would suggest to you that when somebody asks us, how do I measure push rods, they're saying, how do I know I have the right length push rod in my engine?
Well, that might be the whole
Because
thing. That's all.
You can put, people will say, this cam hadn't got the lift it's supposed to have, or it doesn't this, or it doesn't that. Well, if you've ever played with an engine, played with the length of the push rod, you can change
The rocker ratio.
dramatically the rocker ratio and the lift and everything.
And sweep across the
and
valve where the force is.
you know, it's important that the rocker arm hit directly on the center of the valve and push it down instead of pushing it sideways, and it'll cause wear in the valve guides and everything else. So it's, Comp has tools that you can check the length of the push rod, and as do everybody. I mean,
Yeah.
it's nothing just for Comp, but it is very important when you build an engine to put in your push rod, set your lash, and roll it over while you're looking at the rocker arm pushing on the valve. And do it over and over and over, and just study on it. And then just for kicks, change the push rod length 50 or 60 thousandths and watch it move over to the side and start,
Right.
instead of staying in the center. And it's a big deal.
Right, little blue dicom on the valve tip.
We had
You go in there, put you can use the ones that screw out, our adjustable
Yeah.
push rods. Put that on there, run it through. You can dicom it. You can play with it to get it right.
Right, so we're talking about the not the XDA adjustable, but the adjustable length checker tool.
Yeah.
So you're comfortable saying then use the measurement on the tool dead on. We're not.
Right. If once you have the length of the push rod, you can check it with the caliper. The difference between a gauge length and the other that people get all spun out about, it's like 15 thousandths. That's not going to be a big change on geometry.
You heard it here
50,000.
first, you guys. This guy is the expert on this much is a big deal. He says in this case, it's all right.
Yeah, the
We're gonna be
fighting
okay.
between the two is not going to cause you a big problem.
Okay. So there was a question actually about the XDA push rods. From a drag racer, I'm interested in the new adjustable push rods, but I'm very worried about just abusing them. How do they stack up to a standard piece?
The XDA, we have beat those things left and right. What's funny is, and we didn't quite get it at first, that the bottom part of it's 7/16, the top part of it's a 5/16 105 wall. We know what both of those will do. What we didn't understand until we started testing is that having them combined does better than having them apart. Meaning you would think that, a 3/8 is right between a 5/16 and a 7/16.
Right.
So if you mix a half 5/16, half
You should just
7/16,
average it out.
it should be like a 3/8. So we did exactly that test. What we're surprised at is the frequency. It acted way stiffer than it should have. And then, of course, that starts making you do some math, right?
Right.
Where did I'm supposed to be good at math.
That makes
It's
you
good
do
to have
math.
a
It
nuclear
doesn't make me
physicist
do
around.
math.
Right, I'm like, what's going on? And it reminded me of the old Mauser barrels. If you ever saw a World War II German rifle,
Yeah.
it had steps in the barrel.
Yeah.
The
Depends
reason-
on whether you're in front of it or behind it, how important that is.
Yeah, right, exactly. And what they were trying to do, it wasn't they didn't know how to take the barrel, put it over the compound and make it taper. They were actually trying to get different frequencies, so when it shot, the whole barrel wouldn't ring and vibrate. And what we saw with the by going to taking 3 inches out of the overall length of the 5/16 section of the push rod, instead of now, the bending goes as length cubed. So if you
Who
take,
cares?
okay, well,
You know,
5 times 5 times 5.
I know, but
But
let's
Scooter's
back up a
actually the
little
one
bit.
that sent in the question.
Okay,
He's a
well,
drag
okay.
Let's
racer.
back up a little
Yeah.
bit. When I was a youngster coming into this many, many years ago,
Uh-huh.
the whole big deal was you weighed the part.
Right.
I said, well, lighter's got to be better because it's doing all this movement. And prior to any way of measuring it, strain gauges, Spintron, strobe lights, all that, we believed that.
Right.
And now you see the whole thing is changing to the other way, that stiffer is better in almost every case that
Right.
on that side.
Mhm.
And that's what's led to a bigger, stronger, heavier, stiffer push rod. And Billy's new whiz bang 3-piece something is just, part of the problem with an engine is you can't fit it in there. There's no real estate. And so, Billy
This
so
might have been my own race
conveniently
car.
does,
Yeah.
found a way to do the impossible and fit it in and get the advantage of the stiffer valve train and the bigger push rod. Well, it would still go in the engine and use a smaller one. So there's a whole lot of things, and we can talk about all the numbers and all the anythings, but it's probably a quantum leap in technology as far as controlling the valve in very extreme circumstances. Let me just put it like that.
Right, it puts a very extremely robust, the heavy piece down at the bottom. It puts the small piece where it can go through the port, and together that actually works a lot better than the in-between piece would.
And let me answer the real question. The question was, what about durability, I think?
How about abuse?
That's what it's designed for, a 24-hour type
And again,
application.
if everything's in control,
Yeah.
it'll look perfect. You remember when we were really going crazy working on the NASCAR plate engines, restrictor plate engines.
Mm-hmm.
We had some applications where we had 70 pounds of pressure, seat pressure on the seat,
Mm-hmm.
150 over the nose. A third, a fourth of what people would typically have run, but it was so in control that it followed the shape, and it was perfect, and parts looked brand new at the end of the race. And a valve train that's in control with any kind of push rod will look like brand new parts after it's run.
Mm-hmm.
One that's out of control, I don't care what the parts are,
They're
is gonna
terrible.
look horrible. So it's control is the big thing. Billy was talking about reading your parts and looking at your stuff. A racer would do himself well one night, go uncork a bottle of wine and sit down and really study your push rods and your retainers and your locks and that, just for little witness marks and what's going on, what's happening.
Right.
They're going to throw me off. I'll never be invited back to do this, but
Me either, so it'll be good.
No, you're
I was in John Force's trailer years ago.
Mm-hmm.
I really don't know how I ended up there, but I did, and Austin Coyle or Bernie Fedley or one of them was saying, man, I keep burning up this spark plug every time on this one cylinder. I put more fuel in it every time, it burns it up, just this one cylinder. It does it on all my engines. So, well, it's easy, it's a push rod. And he looked at me like I was the craziest man that ever walked the earth. How can it be a push rod? I said, well, let me see. And looked at it, and you could see a little ring around it. I said, well, there. So that thing is bending and, touching the head gasket. Shazam! He said, I've been grinding that out bigger and it still does it. And I was wondering what's going on. I said, yeah, the push rod's bending. The valve is trying to figure out, is the push rod saying going this way or this way? The valve says, I don't really know. Well, the air that's coming through there is going to do what the valve says. And the air says, holy shit. I shouldn't say that. But this valve's telling me to go this way, and I'm trying to go this way, and I don't know what to do. So it burns the plug up. And again, I go back to control. Here, he's been working on the fuel injectors and the fuel system and the spark plugs and the timing, and the real problem was something else. And that all goes back to what we've been talking about of the initial thing of testing and knowing and
treating everything as a system.
And
there wasn't any throwing apart, because that
No.
was just a clearance issue.
he was trying to fix the problem. The problem was burning the plug,
Right.
he thought.
Put
But
more fuel in
what
it,
started
more-
the problem
Yeah.
was way upstream.
Yep.
So, pretty critical.
I'm going to ask a follow-up question of one of the questions we've got running up there. Damian King says his background is predominantly overhead cam. He's got some pushrod questions. I'm not sure if you're asking us about analyzing the current options in overhead cams, or if you're asking about pushrod motors. So,
I think
clarified on that.
I have a feeling he's interested in spinal tap.
Oh yeah, he mentioned the
Yeah,
spinal tap
that's what,
project.
you know.
So, do you want to talk a little bit about what that is, and Damien, get back to us, and we can get an answer for you.
So y'all were
Okay.
really lucky because I don't have my glasses and I can't read that stuff.
Well, you're good, because what Scooter doesn't know is we were joking around like, how high can we take an LS motor? So we're doing this with Ben over at EFI University. It's like, well, can we go 10,000? Like, well, everybody goes 10,000. And NHRA just put a rule at 10.5 because that's supposed to be, if you go over 10.5, it's
In
bad.
pro stock.
Right, in pro stock. So we're like, okay, let's go 11. So I don't know if you've ever seen the movie Spinal Tap.
Yeah,
but,
yeah,
you
turn it
know,
up to
you
11.
turn it up to 11. Why does it go to 11? Because mine goes to 11. So we've been playing with things, and this one has some special lifters, has special push rods, has a cam design that's made for competition eliminator. It's got some of the best valves, valve springs. It's got an RHS block, RHS head, and eventually we're going to get this thing going. It's actually at the problem is we tried to run the cam and everything on a block that wasn't as sophisticated as the real motor, and we tore everything up. So we're going to go back and try to put it together like a system.
Right.
And have you heard that here today?
Yeah.
Way
So-
more stuff that I don't need to hear about.
Yeah, you don't want to know anything about this one. This is going to cost you a lot of money.
Yeah, but it's all in the name of better development.
Oh, yeah,
that
'cause-
eventually trickles down.
Well,
right?
that's the
I
whole
mean,
thing.
that's a
One of
big
the
thing we're
one of the
talking
questions
about.
that we saw that was sent in was talking about working with sanctioning bodies.
Right.
You know, working in professional racing and what comes back to the street, and it all comes back. You know, we get ideas everywhere. We do everything from like scooter sets, from weed whackers to ship motors. We do from
To iron
Briggs.
lungs.
Briggs, you know, there's actually a compressor that's on a Air Force fighter jet that we helped design the compressor load.
Because it's all
The
a
cam,
camshaft.
right, it's just a camshaft. So, you'll learn something in these applications that you never thought, like the deal that we learned in a Top Fuel, you can apply to a NASCAR. What you learn in NASCAR, you can put to a Pro Stock, what you put in Pro Stock. And
That's
all
why
of
the
this-
weed whacker people came to us.
Right,
Because whatever, we don't know what's going on here.
yeah, these
but
are
these
two-stroke
guys
guys.
understand
Right.
how to
Right.
fix problems, and he's still got the little weed whacker engine on his desk, and
Yeah, and it's
Um,
fun, because
yeah.
people don't think it's real, and they look at it and go, hold on, this thing's like a real motor. Yeah, it's a real motor, it's got a camshaft.
Yeah, so I mean, the trickle down, everybody wins, right? We
Right,
start out
it
major
really-
development at such a high level.
Right,
everybody
it
wins.
really is a great deal. One of my favorite classes that most people don't talk about is if you look at the 24-hour Le Mans and 24 Hours of Daytona. If you look at the IMSA classes, a lot of the parts, you look in the Corvette GTLM class,
Yeah.
or the Fords in the GTLM, those parts, there's actually a camshaft in my own BMW that was from one of the GTLM Corvettes.
You might know some people there.
Yeah, right. So, you know,
so
you get.
which one did you want to win?
I wanted to win all of it. Actually, the best one we ever had, one year at the 24 Hours of Daytona, there's 4 classes. You know, they have the 2 prototype classes and the 2 GT classes. You know, the prototype challenge and the Daytona class. We won, the Ford Ganassi won with the V6 overall. The prototype challenge was another one of our customers, K-Tech won it. The GM Racing won with the Corvettes and GTLM. And Aero had a car running a Viper in the GT Amateur. So there was 4 classes. We had a Cam, we had two Chevys, a Ford, and a Chrysler, and they all won. And I guess the Ford won because it had 4 camshafts in it, where there was only 2 in the 2 Chevys.
Not that he would have had the big head after that.
No.
Not at all.
So this one is a product-specific question that came through, and something I've seen a little bit personally. The new Ultra Gold rocker arms, I think specific to the LS,
Mhm.
is what I'm thinking, are the same part number, but they are taller than their
Right.
predecessor.
Right, and basically what happens is aluminum is a great material, but aluminum has problems with fatigue. Meaning that as it bends back and forth, there's only so many times it can bend back and forth before it work hardens, cracks, and has a fatigue failure. Steel isn't as bad on fatigue failures as aluminum. When we first came out with the aluminum rocker arm for the LS, and you'll see this in some competitors' parts, that they try to make them really thin and fit under the valve cover.
Yeah.
And that works great for maybe a minute, maybe an hour, maybe 10 hours. But you start getting 100 hours of runtime, even if it's a very calm system, in the bending, it'll start to, you'll even be able to see, you'll look at the anodizing, you'll see the cracks form.
Right.
And eventually it'll snap. So we had to make it thicker so it wouldn't bend as much, give it some stiffness and make it work.
And it's
Continuous
very,
delivery.
it's not an accidental shape.
No.
Sure.
It's not just make it thicker,
Mm-mm.
because when, they've got all kind of whiz-bang programs that they can put the shape in, and it'll tell where all the stresses are and all that. And we had to put the metal, it's kind of it's like
an
this,
arch.
and when you push over this way and it goes down here, that helps transfer the forces, and it makes it way stronger because of that little bit more metal.
Now, if you're ever touring Italy, you'll see those aqueducts that
Yeah.
Romans put up with the arches.
Yeah.
They're still there. They've been there for 2,000 years.
Like maybe there was something in there.
Like, maybe there's something to it. Now,
They
when you
had
look at
one
the
of those
rock
fancy
art-
computer systems, I'm sure.
I hadn't figured out where they had the FEA system in there, but clearly they did. But, you know, it's a little bit of modification on that, but you can definitely see some of the arch inspiration in the rock arm design.
Sure. So here's another product question. Can you tell us the difference between full travel, reduced travel, and short travel lifters?
Yeah.
Yeah, I want to hear this.
Oh, this is really nice. Now, this is funny because this is something, okay, let's start with the full travel. What the full travel lifter is basically the way the OEs designed it was when you bolt everything together, they wanted to be toward the middle of the travel.
Why?
It was,
And
with production tolerances, so if everything's one way, everything's the other, that it would be somewhere in the sweet spot in the middle.
plus, everything moves when
Right.
it gets hot.
When it gets hot.
Everything changes
Right.
from when you set the valve lash and it starts running, everything changes. So you gotta have some,
And on the OE world, you have a deck height tolerance, you have a cylinder head tolerance,
And you
have
have
a valve length tolerance.
that guy on the assembly line that's just running stuff down like
Right,
that.
and he didn't want to
And,
check anything.
You don't wanna tell him, 20 thousandths off of solid, or
Right.
he doesn't care.
So most of those guys will set up with about 180 thousandths, and they are fine anywhere from about 20 thousandths to the top to 20 thousandths to the bottom. Anywhere in the middle works great, and that's a full travel lifter.
Right.
But what you find out when you start doing some testing is that we used to recommend very light preload, like an eighth of a turn to a quarter turn,
Mhm.
10 to 20 thousandths preload.
Yeah.
And what we'd see there is if you went through a bad spot, the piston couldn't come up and hold the valve off the seat.
Right.
If anybody's ever spent some time around a dyno, sometimes it looks like Eeyore with a little cloud over it. You'll go into some valve float and the valve will hang open and the fuel gets kicked back out and it makes a little cloud over the dyno, over the carburetor. Not so much.
Can
in
I answer the
filters.
guy's question
What?
of what's the difference in the lifters?
The amount of travel.
Yeah, if
Phew,
you've
stop
got
this
a,
much.
Yeah.
if you've got a lifter body here
Uh-huh.
and the plunger inside of it, and the little clip that holds the plunger, everybody's probably seen that.
Mhm.
And there's a distance from where it is against that clip to where it bottoms out.
Right,
And that's the travel.
right.
And initially, you want to put it somewhere in the middle, so it's got a whole lot of,
From an OE standpoint.
yeah. Well, again, remember what I said about the air trying to figure out what it's doing? Well, you got this plunger
It's
that's trying to figure out what I'm doing. And if you run some real high RPM and the valves go a little crazy and the pushrod separates from the lifter, the plunger says, oh, I've got to go this way. And it's all pumped up with oil and the pushrod comes back down and all of a sudden the valve's hung open and it causes popping out the manifold and ugly, bad.
Right.
And so what we did is reduce that travel a little bit so that there's less of that able to be done. It's a little more difficult to adjust them.
You have to get the right length push rod
You
back
have to
there.
get it right, yeah. But and it's not for everybody. But for the guy that wants to spend a little more time and a little more trouble getting it just right, that works.
There's some really good reasons to be near the top of travel. There's some really good reasons to be toward the bottom of travel. We
Right.
talked about the top of travel. Toward the bottom, you want to minimize that volume because oil is very incompressible. We can argue about how incompressible, but it's very
Right.
incompressible. The little bubbles in the oil, they're very compressible. You can't get all the bubbles out. There's always going to be some aeration in the oil. So you've got the little bit of squeezing. How do you minimize the compression? Minimize the volume of oil. So a short travel lets you go close to the top, which is good, and close to the bottom, which is good, at the same time. The negative is you have to take the time to get your push rods right.
Okay. So I'm going to go ahead and reiterate here, you guys. We are asking the experts. So we've got Billy Godbold, we've got Scooter Brothers, and we are asking all sorts of highly technical and occasionally less technical questions of them. We've got some especially less technical questions coming up, so stay tuned for that. To get to Damian King, he is sick of us talking about pushrod motors.
Me too.
So Damian says, I guess what I was wondering initially is that the technology available in pushrod valve actuation seems vastly more detailed, more available than what's available within the aftermarket for overhead cam engines. I would generally agree with that. Maybe Billy will disagree. It seems like many dimensions in an overhead cam motor are fixed.
Yeah, when you really think about it, you can't move you take a new Ford Coyote motor, which I absolutely love that motor. You look at the new V6 that's in the GT.
Mm-hmm.
Those are designed where there's just not a lot of real estate to play with.
Right.
So you have to be very careful with those.
You gotta be careful and you gotta be smart to trick it.
Right.
It's very subtle,
Right.
the little things you do. And what we got away with for years, one of the biggest lessons to learn on the overhead stuff is to make little bitty tiny changes and sneak up on it.
Right.
Because we're used to being able to make big changes
Right.
and watch for smoke when you plug that thing in. But you can't do that nowadays, and you gotta know what you're doing.
But it's amazing what you can do with the technology. Like,
Yeah.
if you look at some of the stuff that Hot Rod's done with our camshafts, you can take one of the Ford Coyote motors, do a cam swap, pick up like 50 horsepower.
Right. So that was also last year at SEMA. We released a few Coyote-specific products.
Mhm.
So the technology is definitely developing, Damien. I don't want you to think that it's not. It is just a little bit more difficult to field to work in.
Well, plus there's so many different, overhead motors.
Right.
When it comes time to tackle a new application, I wind up having to steal about $10,000 from this guy in engineering time. Buy an engine, take it all apart, see how it works, do testing on everything like that. So it's not like, there might be 40,000 different engine configurations out there.
Right.
We can't do something for everything, or eventually we would run out of money.
But if there's something in particular you're wondering about, again, don't hesitate to contact our helpful techs. We've got the contact information there in the comments. We'll share it again at the end. Excuse me for my stumbling there. One of the questions that came through, the trunnion kits, I'm assuming LS upgrade, were recently updated.
Yeah.
You want to talk about that?
Yeah, well, basically, when we did our first trunnion setup, we did it just like we would a big block Chevy. Now, as you guys are probably aware,
This is the center part of
the
the
center
rocker.
part of the rocker arm, it's the trunnion comes off of the French word for what the cannon's rolled around. And so it's the little part for the middle of the rocker arm, it's a pivot. So these pivots were back in the 80s. We designed these things for big block Chevys, and big block Chevys had a 7/16 stud, which led for a real thin edge for the sides of the trunnion.
Right.
Well, we took everything that we'd done for years on a big block Chevy and put that into an LS. What we didn't realize is that only has like a 10 millimeter stud through it.
Right.
So there's tons of room around the stud for material, but we had the same heat treating. We went ahead and said, hey, we've got so much more cross section. You don't want to use more than a third of the cross section for heat treat. But we could have tripled the case depth on the LS.
For all of
So
you
we thought-
wondering about heat treating your trunnion.
Yeah, I'm sorry. So what we did was we went ahead and we changed the heat treat on it. We changed the material, went to a little bit better material, a deeper heat treat, and then we put 4 oil slots in the top to try to get more oil that comes on the side of the rocker. We'd see kind of puddle there.
Right.
We're trying to channel it and get it to go down in the needle bearings. And I think the combination of the things really, really helped.
I would agree with that. We've seen a lot of really happy customers with that.
Yes,
upgrade,
very
so.
much.
More LS questions. It's like
Yeah.
I wrote these. I promise.
Is
I
there
didn't,
nobody
you guys.
out there that's got anything but LS's?
There's a guy with
Probably
a
the
single
one-
overhead cam
yeah,
Ford
they-
that's about to call.
Overhead cams.
No, single overhead, the SOHC Ford, 427,
Okay, well,
NASCAR motor. That was legal for what, a year?
Maybe.
So on an LS, how do you decide between dual spring or conical?
My car has a conical in it. If somebody's asking me,
Yeah.
I'd run a conical. The thing is, the conical, you have to think of each spring. A spring isn't just a spring.
Right.
Each coil acts differently. If you go with high-speed video, and we probably have some that you guys could link.
Because Spintron.
Right, yeah, yeah, thanks, thanks, Trent. When you start moving that retainer down, the first coils start coming together and this wave goes through the spring.
Right. It's a really cool, actually, to watch.
Oh,
pretty neat.
it's like, it is so awesome, but each coil in a conical has a different frequency. And we've done some of the strain gauging we were talking about earlier, putting strain gauges on each coil to see how much stress it's under. With a conical, we can make each spring, each section of the spring, 5, 6 different sections, act differently.
Put a different frequency in each
Right.
coil is what you're doing.
Right.
That
Right.
just, you see, some springs have dampers in them, and the whole reason is frequency.
Right.
And you can you can play a guitar and move your fingers around. That's the same thing as a damper does.
Right.
And the spring, if you can put all different frequencies in each coil, then all of a sudden you don't have to do that. And the real answer, do I want a conical, or do I want a beehive, or do I want a dual spring, is that you want the right spring.
If you were having a relay race up a mountain, and you could think about you had 6 scouts, you know, that you had to race up the mountain.
Right.
They didn't all have to run the same distance. You'd probably put your best runner last and have him do the longest deal if he's a good distance
Right.
runner. If you had somebody who could barely get off the couch to turn channels if the remote went dead, you'd probably have him at the first and have him just go about 10 feet. The conical spring's sort of like that. The big nose tackle, who was that, Vince Wilfork or something for the Patriots? It was like this huge dude. He's down at the bottom. And then you have the little receiver up top, and he's got to run a lot more. So have the big guy at the bottom moving the least, and the little guy at the top. When you have a dual spring, all the guys are the same on the outer, and all the guys are the same on the inner. And they're rubbing on each other to try to keep from going crazy, which generates heat, which is bad. And they've got to be heavier. So we're trying to let the receiver run the long route, the nose tackle run the short, and it really is kind of cool.
You guys, we better get back to race car analogies,
sorry.
or I'm going to be lost forever. So we interrupt the football show to bring you another LS question. On a hot street LS, which is better, a hydraulic roller or a new tight lash solid roller?
Uh-huh.
The answer is yes.
Yes.
What I would do is I'd put the solid roller, because I don't mind the effort,
Maintenance.
the
Right, the
maintenance that it's
time.
gonna take. If somebody wants a toy that they just wanna go in there and crank up and go play, then they want a hydraulic roller.
I have the XDAs in my race car, and we're kind of good at it, and it took 4 hours one night to set the lash perfectly. Now, we were able to leave it there. We run thousands of miles. The lash is still perfect. But, you know, that's 4 extra hours of time, where if it was a hydraulic roller, just slap it in.
Yeah,
The power difference probably doesn't matter. Now, my idea of going to solid roller was, okay, I can put it in a turn. If it picks up the oil pump and air gets in there, it won't mess up my hydraulic roller lifters, which is totally true. However, I found out that main bearings don't like air in the oil system.
That was what I was gonna say. None of that stuff made any difference because something else failed first.
Right, exactly. Air in the oil system is bad.
Yeah,
As it turns
typically
out.
bad.
Right, I didn't know. The bearing guys have told me that.
Let's do one more I've got here. How do I set hydraulic preload? You got any pro tips?
I mean, what I like to do is go in there and put a dial indicator coming down parallel with the push rod. And as you're tightening down the rocker arm, watch from the time that it just takes up the slack, so you just barely spin the push rod, and watch how far it goes down. And there's people that like to do the turns and everything. I'm sure you've always done the
It's
turns.
really the same.
Yeah, it's the
But you
same.
gotta know how many turns means how many thousandths.
Right.
And and you go back to what we were talking about, of getting that thing in the middle.
Mm-hmm.
Once you get that in the middle,
Right.
that's how many turns or how many thousandths or whatever, and they're all different. I don't think there's one answer to that.
No, the thing is, the slapping together is probably the wrong answer.
All right. And 4 hours of valve lash is a different answer completely. So that's a choose your own adventure, you guys. Billy Carroll wants to know, Billy, about the 3 ways to eat a hamburger.
Oh, okay. That he's talking about the, we always joke about how you make power with an
Is this
engine.
a hamburger or a shit burger?
This is a hamburger. The shit burger, you told me, you do that really quick because it's not
Yeah.
going to get better over time. Okay. If you have a bad phone call to make, do it quickly. Okay, hamburger thing. What he's talking about is, when people talk about making power, people come up with this all the time. Oh, I've got this new thing. It makes this much power. And you're like, well, does it make more power because of volumetric efficiency? The engine's moving more air. Or does it make more power because of brake-specific fuel consumption? That you've got less friction, you've got better combustion efficiency. And so the joke is running about how to eat a hamburger, is volumetric efficiency. 100% volumetric efficiency would be eating the whole hamburger in one bite, which may not taste great, but it's kind of a good idea to do when you're trying to make power.
Oh, okay.
And then the whole idea, the Gordon joke is about Gordon Holloway, who's worked here since like 12 years before Cams or something. He'll talk about 115% volumetric efficiency is like you're eating the smell too. So how to eat a hamburger.
All right. Well, guys, we posted a ton of helpful links and all kinds of just information, really. We've got cool videos, that Spintron footage of the Conical Springs, all kinds of stuff in the comments. Make sure that you follow that and interact. Continue to ask questions if you've got them. We will follow those up. And we'll be featuring a new expert here shortly, and we'll be doing a full series of these, you guys. So we really appreciate everybody tuning in. If there are any last-minute questions, please feel free to ask those. We are going to recap with Billy a little bit on what's going on in engineering,
And I'm gonna be spying on all the experts and everything else to see what kind of lies they tell.
No, it'll be fun.
it sounds like we'll be welcoming back Scooter for the series, and we have a good time here. So thank you all for tuning in. Stay tuned to learn a little bit more about what is going on in engineering, you guys. All right, and more tech information. So we were talking about just the size of the engineering team. I got cut off a little bit on that first video that we did.
Yeah.
So what's going on back there? How do you guys have that set up? I mean, we have a full engineering department, so a large group in our company.
We move somewhere between 24 and 30 some odd engineers, depending on who's coming in, who's going out, and what they're doing.
Right.
So
We have a lot of projects that sometimes we have to go and draft some other people on the team, and we have a lot of what I call our extended family of engineers at other places too that we work with. So
yeah, because the team at Quartermaster who does drivetrain, if we're working on a lockup converter for TCI, you might want the clutch guys from Chicago coming down to Memphis and, hey, we got barbecue here. They don't like coming in August. I think it's because of the weather thing.
There may be something to that.
But daggum, in February, they'll show up from Chicago in a heartbeat.
Yeah, and I mean, that's something neat that we've got going on too, is we have engineers who are so good in such very different areas that we have a good opportunity for crossover in a lot of areas.
Absolutely, because you have all the fast guys that are electronics. And so if we're trying to figure out something in valvetrain, like how to move a camshaft around, I mean, we've got the best electronics guys in the world at FAST and can help us so much.
And when we were talking about the overhead cam motors and how much electronics are in those now, which is part of the reason they're so scary to touch, we have guys who are experts with electronics. We have the opportunity to play with things that maybe we wouldn't otherwise.
We have fuel guys, we have spark guys,
we have fuel guys and air guys.
Right,
and smart
oil
guys.
guys even, if you count Lake every now and then. So we've got a great team. And it's just amazing at how well everybody gets along. It's a fun deal.
Right.
We've got young guys, we've got old guys, we've got everywhere in between.
And on that note, I think we have to send Billy back to the engineering cave, and he's going to get back to work developing all kinds of cool new products. And thank you, Scooter, for joining us.
You're welcome.
It's been
It was
fun.
fun.
And guys, like I said, feel free to ask more questions, and we'll get right back to you. Thank you for tuning in. We'll see you later.